Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room, coming to you today talking about angles of polygons. Let's start out with the polygon interior angle sum theory. The sum of the interior angle measures of an n-sided convex polygon is S equals 180 times n minus 2. Don't be confused or overwhelmed. So we've got, for this triangle, 180 minus, or times, holy cow, starting off bad already. 180 times n minus 2. Well, n is the number of sides. 180 times 3 minus 2, which is 180. So the sum of the interior angles of that triangle is 180. For this parallelogram, I've got 180 times n minus 2 again. This one has 4 sides, so 4 minus 2. The 180 times 2 is 360. So the sum of the interior angles of that parallelogram is 360. We have a pentagon with 5 sides. 180 times n minus 2 is our formula again. 5 minus 2 is 3. So this one, the interior angles are going to add up to 540 degrees. So let's use what we know about that to find the value of x. Well, this is another pentagon. So we know the interior angles are going to all add up to 180 times n minus 2, which in this case is 180 times 5 minus 2. Woo, that's not a 2, which is 540. So we can add up all of the angles of this pentagon. 3x minus 5 plus x plus 10 plus 4x plus 8 plus 12x plus 6x plus 7, and that has to equal 540. Let's combine like terms. 3x plus x is 4x, plus 4x is 8x, plus 12x is 20x, plus 6x is 26x. Do the constants. Negative 5 plus 10 is 5, plus 8 is 13, plus 7 is 20. So plus 20, and that all equals 540. Let's subtract 20 from each side. We've got 26x equals 520. That means x is 20. Okay, just a way to help us find angles inside of polygons more. Polygon exterior angle sum theory says the sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360. So we need to imagine that these angles, these line segments that make up this polygon continue out. And we're going to call this angle 1. Woo, there we go. Angle 2. Angle 3. And 4. And 5. And 6. So we add all these up. We get the measure of angle 1 plus the measure of angle 2 and angle 3 and angle 4 and angle 5 and angle 6. You add those up and you get 360. Just like you're going around a circle. Okay? Ways to find the exterior angle of a rectangular polygon. Strategy number 1, find the interior angle and then find its linear pair. So how many, all of the interior angles, oh Lord, my mind is broken. This is a pentagon, so that means we'll use 180 times n minus 2, and we know from above that all of the interior angles equal 540. Well, for the interior angles, we can take 540, and we know there's 5 angles, and they're all going to be the same measure. So those are all equal to 108. So let's write that in here. All right. For the exterior angle, we do 180 minus 108 and get 72. Those make a linear pair because they're supplementary. Or you could divide 360 by the number of exterior angles. So to get the exterior angles, we take 360 divided by 5 and get 72. Okay, this more than one way to skin a cat in this case. You can use either one of those, whichever one makes the most sense to you. Flip your paper over. We're going to find the number of sides of a polygon. If the measure of an interior angle is 150. So we know that the sum of the interior angles we can find by doing 180 times n minus 2. The measure of an interior angle is 150. We could take that times the number of angles there are and still get 180 times n minus 2. So let's distribute here. 150. Oh, that's not 150. 150n is 180 n minus 360. So let's subtract 180n from each side. Get negative 30n is negative 360. Divide by negative 30. We get n is 12. So this is a dodecagon with 12 sides. If we're given the measure of an interior angle is 135, same idea. We use the n minus 2 again, but now we've got 135n equals 180 times n minus 2. We distribute again. 135n is 180n minus 360. We can subtract 180n from each side and get negative 45n is negative 360. Divide by negative 45, and n is 8, which gives us an octagon. Last one here, not least, measure of an interior angle is 144. Same idea. These 144n is 180 times n minus 2. Distribute on the right. Subtract 180n from each side. That gives us negative 36n is negative 360. Divide by negative 36. And we get n is 10. So that's a decagon. Down here below, there's a giant table. Do not be afraid. Let's see if I can shrink this just a smidge. Ooh, wrong way. And it gives us some information that we care about. Interior angle sum, triangles 180. These are going to increase by 180 every time. So 360 for a quadrilateral, 5 sides, 6 sides, 7, 8, 9, 10, 11, 12. The interior angles, each of them, triangles got 3 sides, so 180 divided by 3 is 60. Likewise, 360 divided by 4. So we take the interior angle sum divided by the number of angles. 540 over 5 is 108. 720 over 6 is 120. 900 over 7 is 128.6. 1080 over 8 is 135. 1260 over 9 is 140. 1440 over 10 is 144. 1620 over 11 is 147.3. And 1800 over 12 is 150. Last but not least, exterior angles. 180 minus 60 is 120. 360 minus 90. Remember here we do 180 minus the interior angle. So 180 minus 90 is 90. And then 72, 60, 51.4, 45, 40, 36, 32.7, and 30. It's important to know the names of these polygons as well. They increase, these are how many sides they have. Oh, not 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is pretty straightforward. I hope it makes sense to you. If you have any trouble, you know how to find me, get a hold of me, email me. I'm here to help. I hope you're having a fantastic day, and I hope to see you soon.